So now we have this rule that we've just learned and this one that we actually learned by differentiating again. How are we going to find out a way of figuring out this rule? Well, we never looked at the formal proof for this one or this one, but we can see a rule that makes sense just by looking at the graphs. But once you know these two, or once you've established a formal proof for these, it's quite simple to come up with a formal proof for this one. We can have a look at it here. This is going to be the same thing as finding the sine of x over the cos of x, isn't it? Because that's what tan x can be written as. I've just rearranged that there. Now, if you're differentiating something and it's got x in both the parts and they're divided by each other, we need to use the quotient rule. So using the quotient rule, if I say u is the thing on the top and u dash is when I differentiate that, differentiating sine x, I get cos x. And v is the thing on the bottom, and when I differentiate that, I get minus sine x. Now we can come up with a rule to differentiate tan x. All right, we need to do v u dash, so that's cos x times cos x. That will be cos squared x, or cos x all squared, minus u v dash. Now that's going to be minus sine squared x, but if I'm taking away minus sine squared x, it's the same as adding it, isn't it? Over v squared, which is going to be cos squared x. All right, does anything jump out at you? Can we simplify this? Well, we could simplify it so it's cos x over cos x. That would give us 1 plus sine x over cos x, which is the same as tan squared x. We could do that, but something even easier would be to recognise the whole top of this fraction here and say, hey, that's a Pythagorean identity. Sine squared x plus cos squared x equals 1. So that gives us 1 over cos squared x. And that's the same as, what's the reciprocal of cos? It is sec squared x, or sec x all squared. Now that's exactly what we would have got if we did it the other way, because 1 plus tan squared x equals sec squared x. That's another one of the Pythagorean identities you can build off this one. So no matter which way you do it, this is what you get. And we can now write that in. And we've got a nice little set of identities there that we can work with, so that we can now differentiate any of these. And something that we need to write underneath our little box is that when we're differentiating any trig functions, the thing that we're differentiating, x in this case, must be in radians. And if it's not in radians, then remember that scale on our graph doesn't actually make sense, and the gradient of the graph won't be meaningful. So let's practice using this. Now, both of these examples have two different terms, but with an addition or a subtraction sign in between them, I can differentiate them one term at a time. So this one's straightforward. If I differentiate sine x, I get cos x. And if I differentiate cos x, I get minus sine x. So I sort of hold off putting that plus sign in there, because there's no point adding a negative number. I kind of wait and see and think, what happens if I differentiate positive cos x? I get minus sine x. And that way, I only need one line for this working, and I don't have to tidy it up. Now this second one, I can differentiate one term at a time. The first term's simple. The second term, I've got minus sec squared x. Now you could leave it like that, it's not wrong, but anytime you've got an answer that you think could be tidied up, you might just want to check it in case you can come up with a simpler answer. Now I know this looks like a Pythagorean identity. I only memorised this one, and this one's on my formula sheet as well. But if I want to build one of the other two, one of the ones that has sec squared x in it, I need to consider whether I need to divide one of these terms by sine squared x or cos squared x to get this. So I know that 1 over cos squared x will give me sec squared x. So I need to divide all of these by cos squared x. And that gives me the identity that I want. So now I've got an expression for sec squared x. I can sub that in over here. And I've got, using my brackets so I don't make a classic sign error, I can see that I've got 1 minus tan squared x minus 1. So 1 minus 1, those are going to disappear, and I'm just going to have minus tan squared x, which to my way of thinking is a slightly simpler looking answer than this one.